Part 4: The signals of the forest hook. The forest is talking and most of us don't know the language. What if the forest's greatest power is not just that it can recover, but that it can detect danger early? Not with sirens, not with satellites, not with language as we know it, but with signals, invisible signals, chemical signals, stress signals, signals that move through air, roots, microbes, and relationships. This is part 4, the signals of the forest. And if part 3 taught us how forests reboot after collapse, this chapter asks a more dangerous question. How much collapse can be avoided if the signals are read in time? A forest is not a static landscape. It is a living sensing system. Every leaf is exposed to light, heat, wind, water loss, and attack. Every root is sampling moisture, minerals, microbes, and physical resistance. Every organism is responding to change. To us, a forest can look silent, but biologically, it is full of detection. A caterpillar chews a leaf. A pathogen infects a root. A drought begins to tighten the soil. A heat wave pushes transpiration toward failure. And the system does not simply wait, it responds. Sometimes locally, sometimes systemically within the same plant, sometimes in ways that can influence neighboring organisms. That is where the science gets fascinating. When plants are damaged, especially by herbivores, they can release volatile organic compounds, or VOCs, into the air. These compounds are not random exhaust, they can function as stress-related signals. Nearby plants may detect these airborne chemicals and, in some contexts, adjust their own physiology, altering defensive chemistry, growth priorities, or stress readiness. The exact response depends on species, timing, environmental conditions, and the identity of the attacker. That last part matters, because this is not a fantasy of plants chatting like humans. It is something more interesting, a biochemical signaling system shaped by evolution. No words, no intentions in the human sense. And yet, information moves. A damaged leaf can change the chemistry of its neighbors. A stressed plant can alter the behavior of insects. Predators and parasitoids can even be drawn by plant-emitted volatiles linked to herbivore attack. In other words, the forest is not only reacting, it is broadcasting state changes. And the air is only part of the story. Below ground, the signal layer becomes even harder to see and even easier to underestimate. Roots release compounds into the soil. Microbes respond to plant condition. Mycorrhizal associations can alter nutrient exchange and stress responses. Soil communities shift under drought, disturbance, and disease. Scientists are actively studying how much information transfer occurs through these pathways, under what conditions, and how reliably these interactions shape neighboring responses. That scientific caution is not a weakness. It is a strength, because it keeps us from turning a real biological system into mythology. The truth is already extraordinary. Forests are full of distributed sensing and response loops, and many of those loops happen long before humans notice visible damage. The leaves are signaling, the roots are signaling, the microbes are shifting, the chemistry is changing, the system is speaking in gradients. And most of us only notice when the trunks fall. That may be the defining human mistake in almost every system we build. We ignore weak signals, then act shocked by the collapse. In forests, weak signals appear as stress chemistry, reduced vigor, changed growth patterns, insect pressure, moisture decline, and microbial shifts. In cybersecurity, weak signals appear as unusual login behavior, lateral movement attempts, privilege escalation, quiet configuration drift, and failed backups. In supply chains, weak signals look like delayed components, single source dependence, small quality deviations, regional bottlenecks, and hidden maintenance debt. In organizations, weak signals look like burnout, slow approvals, repeated rework, silence in meetings, rising minor incidents, and small quality escapes. Different systems, same pattern. The disaster rarely starts at the moment of collapse. It starts at the moment the early signal is ignored. The forest teaches a different discipline. Read the system before it breaks. Not just the visible outputs, the relationships, not just the tallest trees, the edges, the understory, the soil, not just what is alive, what is changing. A resilient forest does not survive only because it can reboot. It survives because it is constantly sensing, detecting stress, adjusting chemistry, reallocating effort, changing priorities. trading growth for defense when necessary. Slowing, signaling, and adapting before failure becomes irreversible. That is not perfection, that is intelligence under constraint, and that is exactly what most human systems lack. We design for performance. The forest designs for awareness. We optimize for output. The forest preserves sensitivity. We wait for dashboards to turn red. The forest responds while the signal is still faint. And here is the hard lesson. If your system cannot detect weak signals, it will spend its life pretending to be stable until impact. That applies to networks, to businesses, to cities, to families, to nations. The question is not only whether your system has strength, the question is whether it has sensors, whether it has feedback loops, whether it has signal-sharing pathways, whether someone is trained to interpret what the system is already telling them, because unread signals are just delayed disasters. So, what do we learn from the forest? Build systems that listen, build layered sensing, not single-point monitoring, protect local observers, not just central command, share warnings early, even when confidence is incomplete, treat anomalies as information, not inconvenience, preserve the relationships that carry signals, and never confuse silence with safety, because the forest is not silent, it is signaling all the time. We are the ones arriving late, and that may be the next code we need to learn. Not just how systems survive, collapse, not just how they reboot, but how they sense danger before collapse begins. If part 3 was the recovery code, this is the signal layer, the hidden warnings, the early alarms, the chemistry of survival. And once you see it, you start to notice the same pattern everywhere, in ecosystems, in technology, in organizations. In your own life, the smartest systems are not the ones that look strongest. They are the ones that notice first. If this changed the way you see forests and intelligence, like this video, and subscribe to Hidden Nature TV and Qeosh TV, because the next lesson from the forest may be the one that helps us prevent the collapse we haven't seen yet.